Number 14, chapter 28, number 14. That's where I started from. The number 14 says a transformer has 300 tons of wire in the primary coil and 300 tons in the secondary coil. If the output, if the input voltage rather is 100 volts, what is the output voltage? What we're looking for is the secondary voltage. All right, we're looking for secondary voltage. So number 14, and the formula to go along with that for normally, this should be the formula. The formula should be secondary voltage over primary voltage is equals to secondary turns over primary turns. Okay, right. But if we are looking for secondary, it will now be secondary voltage is equals to secondary turns. Okay, let me put it down here. Secondary voltage will be equal to secondary turns times secondary voltage, primary voltage over primary turns. All right, and your VP is 100, your NS is 30, and your NP is 300. So this is 30, this one is 30, this one is 100, and this one is 300. So this is 300, this is 100, and this is 30. So this is what you are solving. All right, okay. All right, so 25 is the next one. 25, we have a transformer has a primary coil with 500 turns and secondary coil with 2500 turns. When the voltage input to the primary cell is 120 volts, the output is what? All right, so we have secondary turn to be what? Secondary turn to be 2500. Then we have primary turn to be what? 500. Then we have primary voltage to be what? 120 volts. To find Vs, that's our secondary voltage, what do we do? The same formula of the Ns multiplied by Ns multiplied by Vp all over what? Np. Alright, so impute what you have to impute and then solve away. Alright, we're now at 57. The seven says transformer which can produce 8 volts. So it can produce 8 volts, right? Can produce 8 volts from a 240 volts AC supply, has an efficiency of 80%. If the current in the secondary coil is 15 ampere, calculate the current in the primary coil. So what you are looking for is the current in the primary coil. We'll have the secondary coil this time. Alright, so let us write down what we'll be given. 57 will be given secondary volts, which is 8. We'll be given primary volts, which is 240. We've been given secondary current, which is 15. So we're looking for primary current, which is unknown. We're looking for. Then we also have efficiency. Efficiency is 80. And the formula we are using is primary current is equal to Vs, that is secondary voltage, secondary current over primary voltage times efficiency. Oh yeah, plug this into the formula. Plug everything you have there into the formula and you get your answer. Okay. Remember to change efficiency to 0.8, like divided by 100. Remember to change 80 now to its simpler form by dividing it by 100. You're supposed to get what? 0.8. So it's 0.8 you will put in efficiency, not 80. All right. Okay. Thank you. All right. 61. So one says the magnetic flux in a coil having 200 turns changes at the time rate of 0.08 watts per second. The induced EMF in the coil is what? So we're looking for the EMF. We're looking for the EMF. We're looking for the EMF. All right. So to find EMF, this question is actually very simple. Very, very simple. To find EMF, what we need to do is N, that's number of turn, N times the far over the T. And this differ over the T is just this 0.08. That is just it. That is the the time rate. That is differ the T. This is time rate. Differ the T. Differ and the T. That is time rate. And it's what? 0.018. That is differ the T. Then N, you already know N, number of turns, that's 200. So this is what you're just doing. Very, very easy and straightforward. All right. See you in the next video.